All right, listen up. If you're here, you're probably pretty good. You run your scans, you find your cross-site scripting, you cash your bug bounties. You're playing for points.
And hey, that's fine. It pays the bills. But we're not here to talk about playing for points. We're here to talk about playing for keeps. We're here to talk about the huge difference between being a hunter who makes a ton of noise and being a ghost who is never there in the first place.
So yeah, this is not another bug bounty playbook. This is an operator's playbook. We are literally going to tear down everything you think you know and rebuild you from the ground up. And that right there, that's the core mission, to transform you from someone who just finds bugs into someone who compromises targets. It is a fundamental mindset shift. You see, a hunter looks for a flaw. An operator looks for a path. A hunter makes a report. An operator achieves an objective.
Exactly. We're talking about moving with precision, with intent, and with absolute total stealth. By the end of this, you're not just going to be finding vulnerabilities, you'll be seeing the entire matrix. You'll understand how these systems are really built, how they break, and how to bend them to your will without ever tripping a single goddamn alarm.
We call this the Mentor's Gauntlet. It's 5 phases. Each one is designed to break you down and then build you up, but way stronger. We're going to start with becoming a digital stalker, mapping the terrain like nobody else. Then we move to the surgical strike, where precision completely replaces brute force. After that, you become the invisible man, learning to live inside the network totally undetected. Phase 4, you become king of the castle, achieving total dominance. And finally, phase 5, well, that's the perfect crime: exfiltration and erasure.
You stick with us through this gauntlet, and I promise you'll come out the other side as a completely different animal. All right, grab your gear. First stop, becoming a digital stalker.
Okay, phase 1, the digital stalker. This is where I swear 99% of so-called hackers completely drop the ball. Reconnaissance isn't about running some tool and getting a list of subdomains. It's about building a comprehensive intelligence picture. We're not looking for what the target published on their website. No, we're looking for what they forgot they even owned. The dev server they spun up 2 years ago for a project that died, the API for that marketing campaign that no one even remembers. That's where the gold is. Oh, that one's easy. Because it's loud, it's dumb, and it tells you almost nothing of real value. A basic Nmap scan on the main domain? Wow, congratulations, you've just announced your presence to every blue teamer and their damn dog, all to discover that, wait for it, port 443 is open. Groundbreaking stuff. On a real op, that kind of noise gets you burned before you've even started. Elite recon is a paradox, you see. You have to be both aggressive and completely invisible at the same time. It's all about building a complete attack surface map using passive techniques first, understanding their entire digital footprint, their company acquisitions, their tech stack, their developers' GitHub habits, all before you send a single active packet to a primary target. A blind Nmap scan isn't just a mistake, it's a death sentence. It shows you have no strategy.
Okay, so let's get into the core concept here. The absolute foundation of modern effective recon is building an automated funnel. You are not running these tools one by one like a chump. You're creating a machine. So step 1, you use tools like Subfinder and Amass, and you configure them with every single API key you can get your hands on. And I'm not talking about the freebie keys either. If you're serious about this, you're paying for the highest tiers on services like Shodan, Security Trails, Chaos. The difference in data you get is night and day. This is how you cast the widest possible net for subdomains.
Right, but a list of subs is totally useless on its own, so you immediately pipe that output directly into HTTPX. That's step 2, validation. It just weeds out all the dead hosts and gives you a clean, verified list of live web servers, along with their status codes, page titles, and tech detection. It's your first real signal.
From there, the live hosts feed directly into Katana to Spider for endpoints, JavaScript files, and other juicy URLs. And finally, that output can be fed into Nuclei for an initial, very low-impact vulnerability scan, but using very specific, non-intrusive templates. The goal, the whole point, is to have this entire pipeline running on a cron job, constantly feeding you a stream of new, validated, and interesting targets, without you having to lift a finger.
So let's really get into the how. Let's do a technical deep dive. Forget fuzzing for /admin. I mean, that's child's play. We're hunting APIs, and that requires a completely different approach. Just look at this FUF command. It's simple, but the devil is in the details. First off, the word list. We're not using some generic directory list from GitHub. We're using one that is specifically built for API endpoints. Think things like V1, V2, beta, internal, off, GraphQL.
Yeah, and look at the status codes we're matching. -MC, 200, 401, 403. I mean, A 200 OK is great. You found a public endpoint. Cool. But a 401 unauthorized or 403 forbidden? That is often more valuable. It tells you that an endpoint exists, but you just don't have the right permissions. Yet. It confirms a valid path that you can circle back to and target later. You see, a 404 is just noise. A 403, though, that's a signal.
Now, for the real secret sauce, JavaScript and mobile apps. At an elite level, this is absolutely non-negotiable. Scanners will never, ever find what's buried deep inside a minified JS bundle. Just look at this one-liner on the slide. We're taking all the JavaScript file URLs we found with Katana, and we're just piping them into Link Finder. This tool uses regular expressions to rip API paths and hidden endpoints directly out of the code itself. This is how you find the stuff that developers never, ever intended for you to see. And mobile apps? Oh man, they're even better. Get the APK or the IPA file. Rip that thing open with JODX or Ghidra. You will be absolutely shocked at what you find hard-coded in there. I'm talking private API base URLs, old V1 endpoints that are still active but unlisted, sometimes even secrets or keys. Developers just assume nobody's actually looking inside the mobile app binary. We always look. So, time for a war story. We were on this gig, a huge financial target, and they were locked down tight. I mean, we'd been mapping them for a week and found nothing, not a thing on their main assets. It was clean. But our automated recon funnel, it picked up this forgotten subdomain, some old marketing campaign site from like 5 years ago. It looked like total garbage. But, you know, the process is the process. So we ran the JS mining pipeline on it. And buried deep inside this massive, ugly, minified jQuery file from 2015 was a single, commented out line with a base URL. It pointed to an API endpoint v3/internal/admin/functions. On a damn whim, I just hid it in my browser. No authentication. It was a leftover development endpoint that literally listed internal admin functions. One of those functions was provision new user. Well, long story short, we provisioned ourselves a domain admin account. Total, complete ownage. All because some developer got lazy cleaning up an old, forgotten marketing site. You gotta remember, laziness is the operator's best friend. And all of that recon work, right, all that digging, it brings us to the elite take for this phase. This is the fundamental difference in mindset you have to adopt. The bug bounty hunter or the pen tester, they're just trying to build a list of things to test. Their goal is coverage of the known attack surface. They're asking, what's public? An elite operator, on the other hand, is building what we call a canonical catalog. It's a comprehensive, structured map of the target's entire digital existence, both intended and unintended. We're not asking what's public, we're asking what exists, period. This catalog doesn't just list URLs, it maps relationships between systems, it documents technologies, it tracks changes over time, it becomes the single source of truth for the entire operation. All right, you've done the work. You have your canonical catalog. All that deep, patient recon in phase 1 has given us a high probability target. You know, a forgotten API, something that isn't getting the same level of scrutiny as the main application. So now, phase 2 begins, the surgical strike.
And really pay attention to that word, surgical. We're not just going to throw a bunch of exploits at it like a bunch of amateurs. We're going to dissect it with precision. This phase is all about exploiting business logic and authorization flaws, the kind of stuff that automated tools are completely, totally blind to. It requires you to think like a developer and an attacker at the exact same time.
Ah, this is the trap. This is the trap everyone falls into. They run nuclei, they run burp scanner, and it all comes back green. No SQL injection, no XSS, we're good. It's complete bullshit. The application isn't secure. You're just asking it kindergarten-level questions.
Exactly. The most devastating vulnerabilities, the ones that really matter, they aren't in the input parsing. They're in the logic itself. They're hidden in the gaps between what the documentation says should happen and what the server actually enforces when it's under pressure. A scanner can't find a flaw where a user in organization A can pull data from organization B because some developer somewhere forgot a single line of code to check tenancy. And that is exactly what we're going to hunt for.
So, let's talk core concept for this phase. I want you to meet BOLA, or Broken Object Level Authorization. Some people call it IDOR, Insecure Direct Object Reference. Honestly, whatever you call it, it is the absolute money vein of API hacking. It is, without a doubt, the most common and the most critical API vulnerability out there today.
That's right. And the concept is dead simple. The application takes an ID from you, the user, a document ID, a user ID, an invoice number, whatever, and it just trusts you. It never stops to ask the most crucial question, hey, does this user actually have permission to see the thing they're asking for? When that check is missing, the entire system just falls apart.
So here it is, the exact step-by-step operational checklist for finding BOLA. You have to follow this precisely. Step 1, and I mean this is completely non-negotiable, you create 2 separate accounts in the target application. One is your attacker, let's call it tenant A, the other is your victim, tenant B. You absolutely need both to prove the leak.
Then, step 2. You log in as tenant A, and you access one of your own things. Pull up your own user profile, view your own document, whatever. Capture that request. This is your baseline. You confirm it works, you get a 200 OK. Simple.
Okay, step 3 is the critical test. Using tenant A's session token, you replay that request, but you change only one thing, the ID in the URL or the request body. You swap your own ID for an ID that you know belongs to tenant B. This is the rule of one variable per test. It gives you undeniable proof.
And finally, step 4, you analyze the response. If you get a 403 forbidden or a 404 not found, well, congratulations, the application is secure. That's what's supposed to happen. But if you get a 200 OK and the response body contains the data for tenant B, you've just hit the jackpot. That's a critical flaw, end of story.
All right, time for a technical deep dive. Look, the easy IDRs are the numeric ones in a GET request. The ones that pay the big bounties, they're hidden. You have to hunt for them. Don't just look at the URL. You have to look inside the JSON body of post and put requests. Just like you see here, the user ID is tucked away inside the JSON.
And never ever assume that a long, random-looking string is unguessable. Is it a UUID? Is it a hash? Or is it just base 64? Always throw it into a decoder. That YBJ123 you see on the screen, that might just be ABC123. Developers do this all the time, thinking it's security through obscurity. It's not. It's just an annoying extra step for us. Your proxy logs are your best friend here. Map out every single place the application uses any kind of identifier, no matter what format it's in.
Let me tell you a war story. We were testing this big SaaS platform. We found an endpoint for updating your user profile. You know, standard stuff. Put/API users/me. You could change your name, your email, kind of boring. But during our deep recon phase, we'd found an old open API spec file that mentioned a role parameter on the user object. It wasn't in the UI, of course.
So we decided to craft a request. We just took the normal profile update JSON and we added one little line. Role admin. Sent it off. The server came back with a 200 OK. Honestly, we were skeptical. We figured it probably just ignored the extra field.
But then I refreshed the page, and all of a sudden, there was a shiny new admin dashboard link in the navigation bar. The damn developer was using a framework feature that blindly maps every single field in the incoming JSON to the internal user database model. They never thought to create an allow list for which fields a regular user is actually allowed to update. We sent admin, the server just said, yes, sir, and just like that, we had the keys to the kingdom. It was the laziest, easiest privilege escalation I have ever seen in my life. It's called mass assignment. It's beautifully, beautifully dangerous.
And this, right here, is the elite take for this phase. A bug bounty hunter finds that mass assignment flaw, reports it, and gets a nice payout. Job done. An operator, however, sees it as a single piece of a much larger puzzle. They immediately ask, okay, what does this enable? The goal isn't to report a single bug. The goal is to achieve the mission.
Right. Maybe that mass assignment only gets you a low-level admin role, but perhaps that role gives you access to an internal export feature that, it turns out, has a bleepa flaw, allowing you to leak all the user data, and maybe inside that data, you find a hard-coded password for a service account. You see, it's all about chaining. An operator doesn't just find flaws, they build exploit chains. They weave together multiple medium-severity bugs to create one catastrophic, undeniable path to total compromise. That is the real art form.
So you're in. The surgical strike was a success. You've exploited a flaw, and you've gained initial access. The amateur celebrates here. The professional knows the real fight has just begun. Welcome to Phase 3, the Invisible Man.
Getting in is easy. Staying in, now that's hard. This is all about establishing your command and control, or C2, and evading every single detection mechanism they can possibly throw at you. From this point forward, every single packet you send is a risk. Paranoia is now your best friend.
Let's just be blunt here. You pop a shell using some off-the-shelf Metasploit payload or, God forbid, a default Cobalt Strike profile. You feel like a god for, what, about 5 minutes? Then the EDR, the Endpoint Detection and Response Software, sees your beacon.
That's right, because every EDR on the planet has a signature for default Cobalt Strike. Its machine learning model just goes, hey, that network traffic, that weird thing happening in memory, That looks exactly like the thousands of other default CS beacons we've seen before. It's like wearing a neon sign that says, "I am a hacker." An alert fires. Some poor Tier 1 analyst in a SOC somewhere gets a notification, and within the hour, the incident response team is isolating that machine, analyzing your malware, and your entire operation is completely, totally burned. Using a default profile isn't just a mistake, it's operational malpractice. Period.
Okay, let's do a quick technical deep dive on C2 protocols. You have choices, and each one has a serious trade-off between speed and stealth. HTTPS is the most common. Yeah, it's fast, it's encrypted, and it can blend in. But just using HTTPS isn't enough. A beacon that calls home every 5 seconds on the dot with the exact same packet size using a default user agent, that is not blending in, that's screaming for attention. We're talking about meticulously mimicking legitimate services, like using post requests to a URL that looks like an analytics endpoint with randomized data padding to vary the size of every request. Then you've got DNS. This is much, much stealthier. DNS traffic is everywhere inside a corporate network. It's literally the noise floor of the internet. Tunneling your C2 over DNS is incredibly hard to detect. But the downside? It's slow as hell. I mean, you're exfiltrating data a few bytes at a time. This is for your long-haul persistent beacons that you only need to talk to maybe once a day just to confirm you still have access. And finally, you can always use custom protocols over TCP or UDP. This can be highly effective if it's done right, but if you're not careful, a strange custom protocol will stick out like a sore thumb on the network and get you caught instantly. The key is to make your C2 mimic a protocol that's already expected on that network segment. Are you on a segment with a lot of database traffic? Well, maybe your C2 should look exactly like MySQL replication traffic. Context is everything. Let me tell you a war story that still pisses me off to this day. We had a team inside a major aerospace company for months. I mean, deep access. We were moving carefully, living off the land. Everything was perfect. Our C2 was over HTTPS, carefully configured with a malleable profile to look exactly like normal web traffic. The callback interval was set to 60 minutes. But the operator who configured the beacon, he set the jitter to only 5%.
And jitter, for those who don't know, is the randomization of your callback time. So a 5% jitter on 60 minutes means the beacon would call back somewhere between 57 and 63 minutes. It sounds random to a human, but to a machine learning algorithm, it's a predictable, rhythmic drumbeat.
Their next-gen firewall's AI didn't see malware. It just saw a statistically anomalous rhythm, a persistent, long-running connection with a ridiculously predictable callback interval. It flagged it. The whole multi-million-dollar operation, months of work, went up in smoke because of a single lazy configuration parameter. We were burned. We had to pull out completely. Just like that. And that, right there, is the elite take on C2. A pen tester's job is to get a shell fast and prove a point. They use Cobalt Strike right out of the box because it works, and it's efficient for their objective, which is a report. An operator's objective is totally different. It's persistence and stealth. We simply can't afford to use off-the-shelf tools that have known signatures. An elite operation uses bespoke C2 frameworks, or at the absolute very least, heavily modified and customized open-source ones. The infrastructure is meticulously designed to blend in. We call it low and slow. We would much rather have a beacon that calls home once a week with an absolute certainty of not being detected than one that gives us a real-time shell but risks burning the entire op. Stealth is always prioritized over speed. Okay, you're in, and you're invisible, but you're on a single box. It's just a beachhead. Phase 4 is all about expanding that beachhead into an empire. It's about lateral movement, credential harvesting, and patiently, so patiently, mapping the internal network until you find a path to the throne.
And that throne has a name, Domain Administrator. With Domain Admin, you own everything. You are the god of that network. So this phase is all about the patient, methodical journey from that one compromised user account to total, undisputed control.
So the core concept of this entire phase is something we call living off the land, or LOTL. It's the ultimate form of stealth. You see, EDR and antivirus, they're looking for bad files, for malicious binaries. So what's the solution? Well, don't use any.
Exactly. Why drop a custom credential dumping tool like Mimikatz that is going to get flagged instantly when you can use PowerShell, a legitimate signed Microsoft tool, to achieve the exact same result completely in memory? We use the target's own built-in tools against them. We use WMI for remote command execution. We use pexec. We write our tools as in-memory PowerShell scripts that never, ever touch the disk.
By using the native tools that legitimate system administrators use every single day, our activity becomes almost impossible to distinguish from normal network noise. We're not a hacker dropping malware. No, we're just another admin doing their job. That's the whole philosophy of living off the land.
All right, let's get technical. One of the most powerful and reliable lateral movement techniques in any Active Directory environment is curb roasting. Let's do a deep dive. So, step 1. From any machine on the domain, even as a regular low-privilege user, you query the domain controller for accounts that are configured to run services. These have what are called Service Principal Names, or SPNs, attached to them.
Then step 2. As a regular user, you are allowed to request a service ticket called a TGS for any of these services. This is a totally normal part of how Kerberos works. You're just asking the domain controller, hey, can I please have a ticket to use the MSSQL service? No red flags there at all.
Step 3. The domain controller happily complies. It sends you back an encrypted ticket. Now, the important part here is that this ticket is encrypted with the service account's password hash. And remember, you don't need any special privileges to ask for it. It's a feature, not a bug.
And that's the killer move in step 4. You take that ticket offline back to your own machine, and now you can use a tool like Hashcat to brute force the password. You can throw billions of password guesses per second at it without ever sending another packet to the target network. And because service accounts often have notoriously weak, non-expiring passwords, you will eventually crack it.
War story time. We were deep in a network, had a foothold as a regular user, but we were just stuck. Couldn't find anything. So we ran the Kerberoasting playbook. We requested tickets for every single service account we could find. Most of it was garbage, tied to low privilege stuff. But one caught our eye. It was for some backup service on a server that hadn't been patched since the dawn of time.
So we took the ticket offline and started cracking it. Honestly, we weren't hopeful. Figured it'd be some 25-character monstrosity. But less than an hour later, Hashcat spits out the password, summer 2019, capital S, exclamation point. The admin who set that probably thought he was a security genius.
We tried the password, and what do you know? The service account was a member of the domain admins group. They had set it up years ago for this backup job and then completely forgot about it. That one stupidly weak password, found through a completely legitimate feature of Kerberos, gave us the keys to the entire goddamn kingdom. We went from 0 to domain admin in under an hour.
So here's the elite take on lateral movement. The pen tester's goal is speed. They need to get from point A to domain admin as fast as humanly possible to prove it can be done. They'll use noisy techniques because for them, time is money. Their report just needs to show a valid path. An operator's goal is the exact opposite. We don't just move laterally. We move with a purpose that mirrors the business itself. We access the file server at 9 a.m. on a weekday. We query the database in the afternoon. A pen tester leaves a trail of random logins all over the network at 3 a.m. We leave a trail that looks like a sysadmin having a normal, boring Tuesday. The goal isn't just to find a path. The goal is to become part of the network's background radiation, to gain complete, pervasive, and persistent access without a single person ever knowing we were there. In this phase, patience is not just a virtue, it's a requirement for survival.
You are king of the castle. You have domain admin. You have access to everything. The file servers, the databases, the email archives. You have achieved the objective, but you have not won yet. This is the final and most critical phase, the one where more operations fail than any other. Welcome to Phase 5, the perfect crime.
This is all about getting what you came for, the data, out of the network without being detected, and then vanishing, erasing every footprint, every log entry, every single trace that you ever existed.
And that is the ultimate question for an operator. Owning the domain is a temporary state. The data is the real prize. So how do you get gigabytes, maybe even terabytes, of sensitive data out of a network that is being actively monitored by sophisticated data loss prevention systems?
And once it's out, how do you clean up your mess? How do you remove your tools, your implants, your logs, your persistence mechanisms? The perfect crime isn't just about not getting caught in the act. It's about leaving behind a crime scene so clean that the victim isn't even sure a crime was committed in the first place. They just know something is wrong. That's the goal.
Let's get technical on exfiltration, because you have to understand the trade-offs. The absolute stealthiest method is DNS tunneling. You encode small chunks of your data into DNS queries. It is brutally slow, but it's almost invisible, because again, DNS is just part of the background noise. This is what you use for exfiltrating small, high-value things, like password hashes or private keys.
ICMP tunneling, hiding data in ping packets, is pretty similar. A little bit faster, but slightly more likely to be noticed if they're really looking. Then you have what we call HTTPS stuffing. This is your high bandwidth option. But you don't just send a massive upload to evil.com, no. You register a domain that looks like a CDN or a cloud backup service they already use. You shape the traffic to have peaks and troughs to mimic a user uploading a large presentation. You might even split the exfil across multiple protocols to keep any single channel from looking anomalous. You have to make it look boring.
All right, time for one last war story. This one's a cautionary tale. We had a junior operator on a team, sharp kid but impatient. He'd done great work, got domain admin, located the target database, which was a 10 GB customer file. His orders were to stage it and prepare for a slow exfil over HTTPS over the course of a week. But he got cocky. He thought he could be clever and use some fast DNS tunneling tool he'd found on GitHub. So he kicked it off, trying to pull the whole 10 GB database in one go. What he didn't realize is that even a fast DNS tunnel generates an absolutely insane number of DNS queries. So the blue team's monitoring dashboard, which normally shows a few thousand DNS queries an hour from that server, suddenly lit up with millions. The graphs spiked so hard it looked like a damn Christmas tree. It was the most obvious anomaly you could possibly imagine. They knew instantly something was wrong. They isolated the server, found his tools, and the operation was over. All that work, wasted. Greed and impatience will get you killed every single time.
And that brings us to our final elite take. A pen tester's job is to prove they could get the data. So they'll grab a screenshot of a sensitive file, they'll put it in their report, and they're done. Exfil is just an afterthought. For an operator, exfiltration is the mission. An elite operator moves with extreme caution. We stage the data on an internal server first. We compress it, we encrypt it, then we bleed it out, slowly, over days or even weeks, using low-bandwidth channels that mimic normal traffic patterns. And once the data is secure, the cleanup begins. We use the access we have to go back and surgically remove every log entry, every file, every registry key we created. The goal is to restore the system to the exact state it was in before we arrived, minus their data, of course. We want them to argue for months about whether they were breached or if an admin just screwed something up. So, that's it. That's the gauntlet. We've shown you the playbook, from the initial recon all the way to the final vanishing act. You now understand the mindset, the thing that separates the point-and-shoot bounty hunter from the invisible professional operator.
But look, this is not a static game. The playbook we've given you, it works today. But tomorrow, a developer is going to ship new code. A new API endpoint will go live. A new server will be spun up in the cloud with default credentials. The attack surface is a living, breathing thing. It changes every hour of every day.
So the real question is, what are you going to do with this knowledge? This framework isn't just a set of instructions, it's a new way of seeing. So the final challenge we're going to leave you with is this. What critical flaw, born from that constant, relentless change, is waiting out there for you to find it tomorrow? Go find out.